1 over root 3. And you've got to realize once you're operating at this level, at an honours leaving cert level, you're operating at honours leaving cert level, and there is no need to show each tiny step that led to the theory. You know, this is, you've shown your work. You've said that's equal to tan of double. You may want to write down the formula. You know, you might just want to say, hey, tan of 2a is equal to that. But you can write it in that form. It's a common form. It's in all the textbooks. Okay? And the rest of that you're going back into the simple stuff, unit circle and reference angle and cast, being a way of calculating tans, trig functions outside of the first quadrant. We know all about that. Hence or otherwise show this blah 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 blah. Okay, that's cool. So we're going to start off with the result we got. And we're going to say it's equal to 2 times, and let's just call that x. 2 times x over 1 minus x squared. Ooh. Root 3 coming in here into a quadratic. So we're going to have to turn this into a disguised, a power 4 formula. What do they call it? I mean, they call it quintix, but they also call it square of a quadratic or something really simple. Anyway, you know, it's a power 4. Why will I do that? Because I do want to get rid of that. Or we can just use the calculator to do so. So first, let's just do a little sneaky thing here and negate both sides. Okay. Now let's go ahead with our multiplying, cross-multiplying. And actually, let's just pass it over to technology now. So we're going to have x squared minus 2 root 3x minus 1 equals 0. Now there is a theory there that says if this is rational, if all the coefficients are rational, the result is always real, I think. No, it isn't. Anyway, I don't know what the meaning of this is, but it doesn't matter. We'll just use them. We'll just plug really quickly the coefficients into the minus b formula. And do keep in mind we only want the positive result because we are in the first quadrant. Okay, so we will be dismissing any negative results because a negative result for tan means a negative angle. Provided you're within the first, provided you're from minus 180 to plus 180. So it's very simple. You take your calculator, you plug, you turn it on. That'll be helpful. Am I on? Yeah. You plug 1. Now you see that tiny writing? That's a hopeless disaster. Let me show you how you get out of that. I was fooling around learning how the calculator works and I ended up leaving something on. So let me show you how to come out. So basically, you're going to want to go way down to the bottom here. No. Input, output. And it's saying to me, do you want... No, it's not there. Let me find it first. 1. Yeah, you want to go just straight up, go into setup and take the very first option. And just go, I advise you to do this no matter what. Go in there and say, do you want math? No, you want option 1 there. I'm not too sure that fixes it for me. Okay, I think that's as big as it gets. But there is a way to get 3 or 4 lines. And the past 3 or 4 solutions, you might go 25 squared equals 625, so on, you know, and a few different calculations, and you can see them all on the one screen. But if you do that, that comes at a cost of having small writing, which I had it set to. Not too sure how I got rid of it. You can ask me about that again. Here we go. 1 stored to a. Negative 2 root. No, careful about that. 1 stored to a. Clear. Negative 2 root 3 stored to b. Negative 1. Again, it didn't come out of that for some reason. I'll double check everything is fine. And then negative 1 stored to c. Okay. There's a slight difference between shift recall and alpha in this calculator, because in this calculator, if you do shift recall, you end up with all the values that have been plugged in. It's struggling now to to focus on that because I'm so close. I'm about 2 inches from the camera lens. But and I'm struggling too, I can tell you. But I'm looking at 1, negative 2 root 3 and negative 1. So it is correct. And that means I can just plug to the minus b formula, and I'll go with minus b plus, because that's the one I want. That's provided this is plus, which it is. Okay, so we're going to go with minus b plus the square root of b squared plus 4ac all over 2a. Here and alpha a. Start again. Could have also done completing the square, maybe. Okay, and now it hasn't come out with, okay, it's come out with 1.338. So what we'll just check is that the same as what they're talking about? And it just didn't, it rounded and it lost the fact that it was an algebraic number. Well, we'll see. But obviously not, because 2 root 3. So I've made a mistake along the way, maybe. So just, you can see that if I'm struggling, you know, take heart in that if you can. Okay, so 2 tan of double angle. So we go back to the very start, go all the way back and check everything. So the tan of a double angle is 2 tans over 1 minus tan squared. 2 tans over 1 minus tan squared. So we want to double that angle, so we're basically talking about the tan of 150. Now the tan of 150 is the tan of 30, and the tan of 30 is 1 over root 3. But there's a negative there, so I believe that this is correct. We can just double check that, see what does our calculator tell us. Of course we know it's true, but when you get under pressure, you negative root 3 over 3, which is the same thing. So I'm going to continue on with that. Now I made another suggestion there, and I'm going to go with that. I'm going to go with completing the square. I did something silly with cross multiplying. Oh look, I multiplied that. I negated there and I negated there. That was good. That was a correct move. I multiplied that up and I multiplied that up. Give me x squared minus 1 equals 2 root 3x. And I brought that back. Whew, everything seems fine. And then I used the minus b formula and things went to pot. So I wouldn't be a big fan of the minus b formula. Using pure mathematics here, using the maths you should be doing, having done all that algebra we did before Christmas, you should be thinking that this is complete square, because there's a 2 here and there's a 1 here. So this should look like x minus root 3 to be squared. And that's going to give me the middle that I want. It's going to give me 3 on the left that I don't want, so I'm going to take away 3 here. Wow. No, I'm going to add 3 here. Good, that's worrying. And I'm going to add 1 here by bringing him over. I'm going to get x minus root 3 squared equals 4. That's good, because we're going to take the square root now. Okay, and get x minus root 3. Now we would normally say plus or minus, but I think we're only going with the plus version. So plus the square root of 4 equals plus 2. So we're getting x equals 2 plus root 3, which is exactly what they have in the exam. And that is what anyone should be doing. Now where I went wrong with the minus b formula, I don't know. I obviously did something stupid. Well, A isn't right anyway, no, it's been changed. I did something stupid. If you used a minus b formula, it would work too. That's grand. That's the way you really should be working it out. So I'll talk you through this again. When this is an x squared and this is even, and has a 2 in it, it's particularly easy. So you turn the x squared into an x, you minus and you divide across by 2, giving you root 3. Then you consider that the first two terms have been looked after. Now this is minus or plus doesn't make any difference here. By the time I have that squared, I'm getting a 3. Well, if I'm getting a 3 on the left that I didn't bargain for, I've got to put a 3 on the right. Then the minus 1, because this is complete squared, the minus 1 has no business here, he has to go. So he comes over to become 1, and we get 4. Okay. Then you solve that, and so on down into this. Okay. I'm going to make up a really quick problem for you. Later on in the course, you're going to realize that, well, I won't use that. Use 2 plus root 7 and 2 minus root 7 as roots. Okay, when I add them together, I get 4, so I'm going to go with x squared ignore. Next question. Okay, I recognize this, and the plus, well, they've given me the formula. Use that to evaluate this. But it is correct, just recognize again, the plus makes a plus here, and if it was sine squared, there would be a minus there. And it's all in your tables on page 14 on the left hand side. So use this to evaluate this. So does it have the right shape? Not really, I don't like it. I need that 2 to come up and the 1 to go across. So this is cos of 2a. Okay. So this is cos of 30. And cos of 30 is root 3 over 2. Down below, oh my god, what's happening here? Hence show that the cos of 15 equals this. Okay. Hence show. So we have 2, let's just call that c squared, where c equals the cos of 15 degrees. Otherwise we'd go mad with our algebra. Okay, so 2c squared minus 1 is equal to root 3 over 2. 4c squared minus 2 equals root 3. 4c squared equals root 3 plus 2. Implying that c squared is equal to root 3 plus 2 over 4, implying that c, now cos is positive up there and we're going to keep him positive, so we'll just drop a square root on root 3 plus 2 over 4. Now that 4 can get out of there because that square root is governing that 4, so he can escape or drop down below, so we call that root of root 3 plus 2, and we let the 4 escape down to become a 2. Sorry. So the 4 was in under and he jumps out and becomes a 2. Okay, prove the following. Let's do 7. Prove the following identities. Where to start? either left or right. Easiest way to do it is start on the right probably, but then we'll do it starting on the left. So starting on the right, this will be 1 plus, now the sine of 2x is 2 sine x cos x. Okay, now let's shove to the left. Let's square this out. We get cos squared plus sine squared plus 2 cos sine. Okay, but cos squared plus sine squared equals 1, so you have 1 plus 2 cos sine. Now the important thing is you never cross that line. You never do anything to the left or the right, because it isn't an equation, it's an identity. Okay, and if it's an identity, you cannot cross that line. So there's no saying I do the same thing to the left as the right. Never, not allowed. But they're equivalent to each other. Now they're equal to each other, and you've proven the identity is true in general, because there's nothing you did that isn't always true. Okay, so I nudged to both of them a little bit. Here it's a simple application. This is really simple. We have, well, in a roundabout way, from here we have 1 minus the cos of 2a is 2 sine squared. So we have 2 sine squared, and down below you have 2 cos squared. So by definition, well, the 2's cancel, and just a little bit of algebra, that's the same as sine over cos to be squared, but sine over cos is tan, so that's the same as tan to be squared, and you've proven it. Okay, so question 9, again, let's call it this the identity line, no crossing the line. Okay, let's get straight down to here. So this is where you're going to see where it really is nice to know your formula, because the sine of 2a we just know is 2 sine cosine. 1 plus